All right, good morning to statistics. So looking at test review for you for final exam. So let me kind of go through and just give you a heads up as to what's going to be on it. Okay. I could go to there. Communications. Okay, so you can see, put up a little bit of things with here to kind of give us a heads up as to what we're going to be dealing with. Okay, let's go ahead and fill this in a little bit. So there's going to be chapter 3. We're going to have descriptive. Okay, mean, median, mode. Mode, range, max minus med, remember, and standard deviation. Okay, so here's some numbers. Tell me this about them. Okay, so I have to do. Okay, trying to remember what else is on there for chapter 3. I don't think very much. Okay, not specifically anyway. Chapter 4, this is the regression and correlation. Usually at this point, I give you a scenario, I do the regression line for you, and then I ask different questions about it. Okay, so every regression I've ever really done, I never used the calculator very much as a tool for that. It's always been Excel or Minitab or something like that to do it. It's not that Excel can't do it. They actually have a really good thing I usually just use slope of the values. Well, it's not like your calculator can't do it. I'm not used to doing regression on a calculator. Usually there's a lot of data to do regression on, so it just doesn't seem to me. It just doesn't seem quite right to do it that way. If you have like 100, here's 100 observations. Good luck. Okay, but yeah, correlation regression. Usually the line is given to you, and I just ask you questions about it. Okay. What's the intercept mean? What's the slope mean? Okay, things like that. Okay, chapter 5. Okay, so chapter 5 is, there's a lot of ands and ors. I usually go ahead and give you guys a table. Okay, it's not going to be a 2x2. I think those are kind of boring, but there'll be a table with different numbers and different things. There'll be totals, and then I'll ask you questions about, what's the probability that, something's in category A here. What's the probability that the category is, we'll say delta. Okay, and just kind of go through that. Okay, so you have to remember what and means. It's the intersection. It is literally the intersection of the table. Okay, and an or, we have an or that's going to be all of these. It's going to be all of these. The problem here is how many times did you count this box? Counted it twice. We're going to have to remove one of those. Okay, so inclusion exclusion principle, probability of A or say epsilon that comes after that, A or epsilon is going to be probability of A plus probability of epsilon minus the probability of A intersect epsilon, because this uncounts it. This removes one of the counts that you have there. Okay, so just remember inclusion exclusion. Okay, if they don't overlap, then you don't have to do, there's no intersection, then you don't have to worry about this. You can just count them up. Okay, but that's what we have for that. Let's see here. Chapter 6. Okay, this was expected value. Okay, now you have to remember, right? It's the value of an event times the probability of the event. Okay, I'm kind of partial to the problem where they had the insurance company. Okay. If you're trying to remember that one, go back to the ebook. Okay. How did I get to the ebook? We had McGraw-Hill. See up here, ebook. So I went to the ebook. The other thing you could do, let me show you this real quick too. Resources. Okay. And you practice exercises for pretty much all sorts of things in here. Okay. So I can go to chapter 6. Okay. And have random variables. That's where our values were. Let me just preview this, and it shows you pretty much all the assignments that they have listed for, so way more than our homework. Okay. But you could find problems that you would want to do, look in here, okay, and get an expected value problem. All right. So you don't have to go back to your homework. You can, okay. If you wanted to go there, you could also, again, right, you could have gone to the ebook. Okay. Let's go to chapter 6, random variables. Now this is going to have more problems in it because not all the problems are in Connect. But if you just scroll on down to the end here, okay. It's pretty much the same kinds of questions that we had before, right? 45. And you can go ahead and do that. Now, again, you can't do that with, you're not going to be typing it into a computer and getting the right answer unless you go through this method. Okay, but there are other ways to do this. Okay. Again, we never calculated a standard deviation from scratch using these methods. I will not be asking you to calculate standard deviation here. Okay, it's just is it a distribution? How do you tell? And then how to do expected value. It's one of these. Okay, so that's what we're looking at for that one. All right. We have binomial. So this is still a chapter 6 problem, but binomial. If you're looking at Poisson or anything like, no, we never did those sections. We never cover them. They're not in the syllabus. They're not something that belongs to the class. Okay, but you have to remember binomial, right? Binom, CDF, binom. Yeah. So I'm going to tell you this: when you're studying, I want you to pay attention to the words they used and try to pick out the key words that tell you if this is a binomial or if this is a normal or what kind of question is it. So most students I've ever had, they are really good at applying, once they know what the technique is, or they've decided on what the technique is, they're very good at using the technique and getting an answer. This was true even when we didn't even use the calculator very much. Okay. If you had to do all of this by hand, students are still very good at coming up with like, oh, I think it's this technique. Let me apply the technique and get an answer. So the thing you want to study when you're looking at binomial is what in the vocabulary, what in how they ask the questions makes me think that this is binomial. Okay. So just real quick, here's your assignment. Okay, again, this is everything in there, so this is terrible. And again, most of the problems I pick are probably about the middle region of your homework. And I try not to pick the absolute hardest problems, but if it's generally, I want to do a word problem. Okay. So let's see here. We have a national college research reported that 67% of students who graduated from high school 2012 entered college. 29 high school students are sampled. Round the answers 4 decimal places. What is the probability exactly? Okay. So what about this? If I didn't know I was in chapter 6, how would I know I was in chapter 6? All right. So did they give us a standard deviation? No, because binomial doesn't need one. Normal needs a standard deviation. Binomial does not. It has one, but we're not going to worry about that. Okay. So what you're going to do is you say, okay, well, we have us, 29 people. Are you going to go enroll in college? Right. That's what this is going on. 67% of the students graduated from high school, enrolled in college. So the question, did you enroll in college after you graduated? Yes, no. If no, that's fine. But notice that's the answer to a yes or no question. We didn't say like how many credits you're going to take, how much are you going to pay. The variable is I enrolled in college after high school. I did not enroll in college after high school. Okay. So there's two outcomes. Okay. We have 29 people here. So we have a sample. We have, drawing from a certain number. We have a static probability. Nobody says normal. Okay. There's no normal distribution here. Okay. There's no mean. There's no standard deviation. Okay. So it's really important. Make sure that you know how and why you're trying to solve the problem. Okay. Like does it fit into the box that says binomial? Right? If I try to do this and I say, okay, well, let's go to normal. Okay. So CDF. Okay, and that you have to remember, right? It's a low, a high, a mean, a standard deviation. I don't have a standard deviation here. Maybe it's 0.67. Well, what's the mean? Is that 0.672? Or we usually don't do that. Use one number for both things. I don't have a low. I mean, it asks me for a probability, but that's about it. So, like Cinderella's stepsisters, like if you're trying to fit into that shoe and it just doesn't work, you probably have the wrong kind of a problem here. And I can't force these numbers into this normal distribution thing here. It's just not going to work. Okay, so it's taking somebody's foot is way too big for a shoe and forcing it to try to fit. And it's going to end poorly, especially if it's a glass slipper. So that's that's my big hint for you. You probably can do these problems. It's just diagnosing which problem you think it is. Okay, that's really the hard part. Okay, so we could do that for binomial. Okay, remember that's common too. If it says more than, it's usually a 1 minus. Okay, so greater than, more than, it's usually going to say 1 minus binom PDF. Okay, so there's other things to check for. Let's say more than 1 minus binom CDF, because the CDF counts from 0 up to a certain number. Okay, so if you have to write a little table out or a little list out, like draw little brackets, 0, 1, 2, 3, 4, 5, and it says a probability of more than 4. What numbers are more than 4? Oh, 5 and above. Okay, if they say fewer than 4, like, well, what numbers are fewer than 4? Is 4 fewer than 4? I don't think so. I think 3 would be fewer than 4, but not 4. So if I said that, you would have to get with those 3. Okay, there's 4. So just be careful about that. Try to think about this. I always find that if I pretend like I'm explaining this to a child or offering a child an option, it becomes a lot clearer. So if you say that you must have more than 2 vegetables on your dinner plate. He said, well, look, I only like mashed potatoes and peas, and I'm not eating any of that broccoli. He said, well, look, you didn't like anything else. I said, you had to have more than 2. So, mashed potatoes and peas ain't going to cut it. You need something else there. Okay, pick something else that's green on the table, not the bologna, and you're eating that. Okay, so I don't care if it's Brussels sprouts, I don't care if it's green beans, but you got to pick something else. Okay. All right. So let's see here. What else are we doing? We're doing this, and we are going back to the announcements. Chapter 7, normal distribution. Okay, again, the most important thing about this. Okay, I didn't ask you the standard normal. I just went to word problems because that's more fun. What about a problem makes you think it's a normal distribution problem? Got a one big hint for you. Okay, I'm not amazed, but I'm surprised that some people don't cue into this. Okay, and it's okay. I get people are nervous too, right? It's all right. So we want applications. Just going to scroll all the way down here and have a look at what's going on. Okay. How much is in the can? So we have the volume of beverage, 12 ounces, can normally, see right there, is normally distributed. They tell you it's not a normal distribution, okay? Almost every one of these problems, they say, oh, it's normally distributed with a mean and a standard deviation. Oh, it's normally distributed with, they want the 90th percentile, whatever, okay? Next one, normally distributed, okay? So the keywords you're looking for on those, normally distributed, all right? We also have something that's similar. We have CLT, right? Central limit theorem, which may also say normal, but it's got some other pieces to it, okay? So if I can scroll all the way up here, we look at 7.3 sampling distributions with central limit theorem. Okay, so this may or may not be normal. I don't know if your book has a lot of those. At the beginning, I think it does. Excuse me. Okay. All right, so if it does say it's normal, but here's what you want to do. Company buys 60 of these cars. Okay, so you have a sample size on top of everything else. Okay. Let's see, needs certain cholesterol, standard deviation. Again, it doesn't say normal, but they have a random sample of. Okay. So it might say normal, which means that the sampling distribution automatically is normal, right? If the underlying distribution is normal, X bar is also normal, okay? If it isn't, then you need a certain number, right? If you don't say anything about it, then you're going to need like more than 30, okay? Because you're going to need a square root in there. So central limit theorem could say normal, but it will always have a sample size. Okay. Chapter 8. Let's see about confidence intervals. Confidence intervals for that. So if I go back and look at the book here, okay, there's a couple of different kinds of confidence intervals. Pretty much they're these, right? Standard deviation is known, standard deviation is unknown, and proportions. Okay, we don't do the rest of this stuff. Okay. But yeah, if you don't know, like, what do they tell you? First off, one of the things they're going to tell you about a confidence interval, okay, is you're going through these problems and studying for them. Get that of the problems. Okay. Construct a 98% confidence interval. Construct a 95% confidence interval. Construct a 95% confidence interval. Construct a certain percent confidence interval. If it tells you to make a confidence interval, then make the confidence interval. Okay, don't look at that and say, I know, this is binomial. No, confidence interval. Okay, so construct confidence intervals. So those are the things you're looking for. Okay, after that, you got to figure out, well, am I doing this one? Am I doing this one? Am I doing proportions? Okay, I'm not going to tell you that all of these came out of the book, because they did not. Some of those are self-written, or other students over several years have written them, and that's what I use. Okay. So it may not be exactly the same wording, but in the instructions, it will always say, make a confidence interval. Okay. Now, sigma versus S, generally, if you calculated the standard deviation, it's a sample standard deviation. Okay. You're using S, you're using a T distribution, T interval. Okay. If they handed it to you, and most of the time in this book, they'll tell you the standard deviation, comma, sigma equals something. comma or period, and then you go on to do something else to explain the problem to you. But if you're seeing this symbol, okay, and it says confidence interval, chances are it's a Z interval. Okay. So if you calculated the standard deviation, mostly that's going to be a t distribution. If they gave it to you, they said the standard deviation for the sample, you're using S. Okay, that's still a t interval. But if you see this symbol, okay, because in statistics class, this symbol specifically means a population parameter, not a sample statistic. Okay, so if you see a population parameter, you know that's the Z interval. Sigma is known. Okay. For proportions, two things. One, make sure you've converted proportions back into decimals. Okay. If the problem says we have 12.34%, then your proportion is equal to 0.1234. Okay, unless it says otherwise, and it won't. Okay, so if you see a percent, you got to convert that back into a proportion, and then you're going to use one sample p interval or something. One sample proportion interval. Okay, so that's all you have to plug in for it. You'll see this is pretty common. Like back in the 70s when I was watching a lot of TV, child, there would always be a commercial on. It would be like 3 out of 4 dentists recommend that you brush your teeth. Okay, so when you see wording like that, 3 out of 4 do this, 1 out of 50 do that, 1 out of 44 do something. Okay, 3 out of 10. That's going to be a proportion. Okay, your X is the number that said yes. Your total out of, right? That's the total number of people they asked. Okay, so that's how to deal with proportions. The same set of skills will actually serve you in chapter 9. Okay, so in chapter 9, okay, this is a test of hypothesis. Okay, you're going to see the words level of significance. Okay, so when you set up your test of hypothesis, and you get your p-value here. So step 1, step 2, step 3, you make your decision. Reject HO, do not reject HO, whatever. Okay, your step 5, and this is important, you must explain the conclusion in a sentence that would make sense to somebody who has not taken statistics. Okay, you must explain this in context of the problem, and so that they understand, because chances are you're going to have to explain this to your boss, and they're going to say, I took stats like 3 decades ago. I don't remember this. Tell me what are you doing and why are you doing it? So we decided to go in this direction because we did a test of hypothesis. It said reject the null hypothesis. You stop there, they're not going to be happy. So what does that mean? Okay, so if your answer is this, reject HO, it's like, are you playing Grand Theft Auto? What are you doing? Okay, reject HO, explain what the heck this means in the context of the problem. Okay, so it says, hey, your water is safe. That's your HO. Your arsenic level in your water is safe level. U equals, I don't know what the value is going to be. We'll say, 0.03, 0.003, and your H1 is mu is higher than 0.003. Right? Nobody's ever going to complain like, hey, there's not enough arsenic in this drinking water. So if you come up with reject HO and you're going to do this, we might have to deal with the water department. We probably want to get a filter. Okay, too much arsenic in drinking water. Okay, for example. So let people know what you meant by this. So if you think, so you have to explain it to somebody who has not had statistics. If you don't write this, you're getting points taken off. Okay, so you have to explain what the heck is going on. Right, and again, there's 3 varieties. Okay, let me go back up here. Chapter 9. Book contents, chapter 9. Okay, chapter 9 section. Standard deviation known, standard deviation unknown, test for proportions. Sound familiar? Okay, it is. It's chapter 8. Okay, so it's all we covered, right? 1, 2, 3, 4. This is the basic stuff. I tend to not test you on types of errors. Okay, so we're looking at these kinds of things. 2, 3, 4. Okay, same problems we did in chapter 8. Okay, so realize that's what you're answering here. Okay, and that's it. Chapter it ends, right? Chapter 9 is the end. We're not going to go to chapter 10 or 11 and deal with that. Okay, so chapter 9, that's the end of the material that I'm testing you over. Okay, so I'm going to go ahead and stop this here. You are welcome to say, hey, could you show us a bunch of test of hypothesis problems? Could you show us a bunch of binomial problems? I encourage you to say, what should I focus my efforts on to show you? Because there's a lot of different kinds of problems, and I don't want to just do the final for you. Okay, so you have to tell me which one do you want to see? Okay, so I'll come up with a couple of problems that I'm going to do for you in the next one, but that's like an introduction to and a general overview of our final exam. All right, so I'll leave you with that. And like I said, if you're stuck with one of them, I just want to reassure myself that's what stuck sometimes means. Like, hey, I just want to see what's the difference between normal and CLT. Okay, that's a good question. So I might do that one in the next video. So I'll stop here, and by all means, feel free to email me about if you're my class. This is December of 2021, so this is that final for that day. Okay, so feel free to email me for that, and we can show you a couple of different ones here. Okay, so good luck, and stay tuned for the next one.